Hey guys, we're going to be continuing here with Chapter 6, and today we're applying what we worked on that last lesson, where we're going to multiply with scientific notation. So it says to multiply numbers written in scientific notation and to choose appropriate units of measure, which is what we'll look at the end of this section. Before we jump into that, here's your daily funny. I love a good camouflage joke. Smith? Yes, sir. I didn't see you at the camouflage practice today. Thank you, sir. Just going to let you sit on that one for a minute for those of you that didn't get it right away. All right, so multiplying with scientific notation, it says multiply 5 times 10 to the 6 times 9 times 10 to the third. Write the product in scientific notation. So first thing is we're going to start with this, but we're going to rearrange this just like we were doing the other day when we were able to rearrange some things because of the commutative property. So I'm going to multiply 5 times 9. And then I'm going to multiply my powers of 10. And I could do this because everything is multiplication, and I'm using the commutative property to do that. So here I have 5 times 9, and I can multiply that out, which is going to be 45 times, and then I have 10 and 10, the bases are the same, so I'm going to go ahead and add those exponents. So I get 10 to the 9th. Now here's the thing, this is not written in scientific notation because 45 is greater than 10. Remember that first number has to be less than 10. So the way you do this is you convert this number to scientific notation. So 45 in scientific notation is 4.5 times 10 to the first, right? I just moved the decimal over 1, so it's 10 to the first times 10 to the 9th. And then after I do that, I combine these because these are they have the same base. So I have 4.5 times 10 to the 1 plus 9 is 10 to the 10th. All right, so those are the steps that you're going to do this. You reorganize this so that the two numbers that go in front of the scientific notation are next to each other. The powers of 10 are next to each other. Multiply these, and then you add the exponents on these. Change this to scientific notation if you need to. If this number comes out to be between 1 and 10, you don't have to worry about that, but this one was not. So we had to go ahead and change that to scientific notation, and then add your exponents again. All right, so here's one for you to try. Go ahead and pause and give that a go. The answer will be up in 3, 2, 1. All right, here are the two answers that I got. So I got 8 times 10 to the 10th. Over here, notice that there's only one of these that are in scientific notation, but I still am going to multiply those. I get 96, which I have to write in scientific notation, and then add my exponents, just like I did on that example. If you didn't get that, go through my work, try to follow it, and make corrections on your own. All right, so here's where you could apply this. A light year, the distance light travels in one Earth year is about 5.9 times 10 to the 12th miles. That's a really long way. A mile is about 5.28 times 10 to the third feet. How many feet are in a light year? So if I want to go from feet to miles, and I know this has this many feet in it, then I'm going to multiply this value by this. So I have 5.9 times 10 to the 12th times 5.28 times 10 to the third. Now I'm going to do the same thing that I did before. So I'm going to rearrange this and put the two numbers between 1 and 10 next to each other. So 5.9 times 5.28 times 10 to the 12th times 10 to the third. And then from here, I multiply these two values, which I get 31.2 rounding to the nearest tenth times 10 to the 15th. Then I got to convert that so that that first number is between 1 and 10. So that's going to be 3.12 times 10 to the first times 10 to the 15th. and then simplify all the way down, and I get 3.12 times 10 to the 16th. All right, so that's just what we did before, except this time now you're pulling it out of a word problem. So that shouldn't be too bad. It's just recognizing that you got to multiply here. Here's one for you to try. Go ahead and pause. The answer will be up in 3, 2, 1. All right, so here is what I got, and here's my work. So if you did not get this, check this against it and see what you did wrong. All right, one more thing to look at. This one's kind of weird. You're going to have to think and know a few things. So first of all, choose the most reasonable unit to describe the quantity. Then use scientific notation to describe the quantity using the other unit. So here it says the mass of a nickel is 5. And then we're looking at grams and milligrams. Now the reason this is weird is because we don't use the metric system very often. So we have a hard time understanding how heavy these different things are. A gram in general, an easy way to remember that is the gram is the weight of about 1 paper clip. A milligram is going to be 1,000th of that. So it's way smaller, 1,000th of this particular value. So how are we going to represent that particular value? So first thing, it says the mass of a nickel is 5 grams is what we'd want to say for that. Okay, grams, because a gram, again, is about the weight of a paper clip. Now it wants us to convert this into the other quantity using the other unit. So we're going to do this using a conversion factor. So I start out with 5 grams. And a conversion factor is when you multiply a value by something that will eliminate this and create a new unit. In other words, if I'm looking at milligrams compared to grams, there are 1,000, which I'm going to say is 10 to the third. There are 1,000 milligrams for every 1 gram. And again, 10 to the third is the same thing as 1,000. A milli means 1,000. So there's 1,000 milligrams to 1 gram. And so here I multiply these two values. Now, some of you may have learned this before where you could look at this and you simplify before you multiply, which also works for units. So in other words, if I have a gram on the top and a gram on the bottom, they're going to cancel each other out. And what I'm left with is 5 times 10 to the third. And I'm left with this particular unit. So 5 times 10 to the third milligrams. All right, so a nickel is either 5 grams or 5 times 10 to the third milligrams, which would be about 5,000 milligrams. You could do this on this one. The length of the football field is about 91. We could use kilometers, we could use meters. Kilometers more closely related to a mile. Okay, so it's not quite a mile, it's less than a mile, but it's a long distance term. A meter is a little bit more than a yard. So if we're looking at a football field, meters is going to be the value that makes more sense. Now it asks us to describe the quantity using the other unit, so we'll do what we just did a second ago. I have 91 meters. I'm going to go ahead and just put that over 1. And I'm going to multiply that by what's called a conversion factor. So how are meters related? If this is on the top here, then I need meters on the bottom here. All right, so meters are going to be on the bottom right here. So 1 meter is the same thing as this. Now this is going to be a little bit confusing, but hang with me here. If there are 1,000 meters in a kilometer, then a kilometer is 1,000th, is 1/1000th of this. All right, so we could write this value by moving it up and making that a negative exponent. Now, we'll talk about this later in the year, but for now, you're just going to have to trust me and write it out this way. Okay, so I'm going from this. My units would cancel out. I got 91 times 10 to that. So it would be 91 times 10 to the -3. And this would be kilometers. And that's how you'd write that basically in scientific notation. Oh, wait, we're not done here. 91 is, hold on, let me fix this. 91 is not between 1 and 10. You guys should have noticed that. I got to change that so that it is a number between 1 and 10. So this is going to be 9.1 times 10 to the first times 10 to the negative 3. I still add these. So 1 plus negative 3 is going to be 9.1 times 10 to the negative 2. And that's how many kilometers it is. And there's our actual answer. All right, so this is a little bit confusing. Just do your best on this. I'm not too worried about it. We will spend some more time on this in class. Here is one for you to try. Go ahead and try it. Just see what you could do. The answer will be up in 3, 2, 1. All right, so here's the answer I got. 7 times 10 to the negative 2. If you didn't get that, don't sweat it too much. I'll give you a lot of help in class on this because this is definitely something that's kind of strange to look at, and we'll spend some time trying to wrap our minds around it. That's it for today, so hopefully you took good notes. I'll see you in class.